Okay, in this lesson we're going to have a look at Unit 2, Chapter 1, Function Transformations, and we're going to be looking at the inverse of relation, Part 2. We're going to focus on restricting the domain of a function so that its inverse is also a function. The first thing we're going to do here is we're going to graph the function, and we're going to graph its inverse. Here we go. The original function is a parabola, as you can see. The f of x equals 2 instead of x subtract 1 squared subtract 3. If I want to graph that function, I want to put the vertex in the middle of the table of values. The vertex of this parabola, you should know from looking at it here, is 1 and negative 3. So I place the vertex in the middle. And I choose two numbers on each side of the x-coordinate. So I would choose 0 and negative 1, 2, and 3. Let's plug these values of x into the equation and find values for y. If we plug in x equals 0, we'll have negative 1 squared, which is 1, times 2, which is 2. Subtract 3 is negative 1. If we plug in negative 1 subtract 1 is a negative 2. Negative 2 squared is 4. 4 times 2 is 8. Subtract 3 is 5. We should also know that the two values on the other side would be the same because it's a parabola and a parabola is symmetrical. Of course, you could always plug those in to be sure, but that's what they will work out like. Let's graph the parabola and see what it looks like here. We got negative 1 and 5. We got 0 and negative 1. We got 1 and negative 3. We got 2 and negative 1. And we got 3 and 5. Let's join up the points to create our parabola here. And here's the graph of the original function f of x. And we can see that it's a parabola as we expected. Okay, let's answer some questions here. Is the inverse of the f of x also a function? So is the inverse a function? And the answer is no, the inverse is not a function. We know the inverse is not going to be a function because of the horizontal line test. Now we can also, of course, plot the graph for the inverse, and we'll do that. But the inverse is not a function. So because of that, I think I'm going to take out this word function up here, because it says f and graph its inverse function. But we already said the inverse is not a function. But we can restrict the domain so that the inverse is a function. So the word function there will apply eventually when we get down to number 2, but at this point it doesn't apply. And you'll see what I mean in a second. Let's interchange the x and y coordinates. 5 and negative 1, negative 1, 0, negative 3, 1, negative 1, 2, and 5, 3. That's of course what we need to do. We just interchange the x and y coordinates in order to construct the graph of the inverse function. Let's plot them and see what it looks like. We got 5, negative 1. We got negative 1, 0. We got negative 3, 1. You got negative 1 and 2. And finally 5 and 3. And here's the graph of the inverse. Now notice I didn't say inverse function because it is not a function. This is the graph of the inverse of the original function. So this is the inverse right here. The graph of the inverse. Is the inverse a function? The answer, of course, as we've already said, is no. We knew that by the horizontal line test, but now we know it by the vertical line test, because the vertical line test tells me if something is a function. It's clearly not a function, because I can draw a vertical line that will pass the graph and put it in one place. So no, it's not a function. Does the graph represent a function? The original graph does represent a function, yes. Does the inverse represent a function? We've already said the answer to that is no. It says to restrict the domain so that the inverse is a function. If I want to restrict the domain so that the inverse is a function, I need to consider what do I have to do with the graph of y equals the f of x so that when I construct the graph of the inverse, it will be a function. And all we simply need to do there is consider the vertex of the parabola. All we need to do is, let me just change my color here, give me a second. All we need to do is consider the x-coordinate of the vertex. The vertex of this parabola is at 1 and -3. If I restrict the domain of the function to be greater than or equal to 1, then the inverse will be a function. Or I could also restrict the domain to be less than or equal to 1. Either one of these restrictions on the original function, on the domain of the original function, will cause the inverse to now be a function. Now, notice up here it says graph its inverse function. I've graphed the inverse, but the inverse is not a function. But I will graph the inverse function shortly. We can do that because of this restricted domain. Let's move to the next slide. Let's consider the function with the restricted domain. Let's do that. Let's consider the domain greater than or equal to 1. So now I'm considering a new function with a restricted domain. Same function that I started with, but a restricted domain. So I'm only going to consider values of x greater than or equal to 1. So let's go back to my table of values. Here are values of x greater than or equal to 1, 1, 2, and 3, -3, -1, and 5. And you see that what I've done now is I'm only going to graph half the parabola. And it's going to be the right side of the parabola. Let's do that. 1, -3, 2, -1, and 3, 5. You can see that I've now graphed just the right side of my parabola. The inverse will be, let's switch the table of values, and let's graph the points again, and see what the inverse looks like. I got -3 and 1. I got -1 and 2, and 5 and 3. Now when I look at the graph of the inverse, the graph of the inverse is now a function. So the inverse is now a function. And the reason why it's a function, because I've restricted the domain of the original function so that the inverse would be a function. So I've restricted the domain of the original function, now the inverse is a function. Let's find the equation of the inverse function. Let's find the equation of that graph that I just produced. To find the equation of the inverse function, remember what we do. We switch x and y and we solve for y. Let's go back and see what the original function looked like. 2 outside of x minus 1 squared, subtract 3. Subtract 3. Okay, step 1, switch x and y. Let's do that. X equals 2 outside of y subtract 1 squared, subtract 3. Step 2, solve for y. I need to take that equation now and solve for y. Let's do that. Bring the 3 over and say x plus 3 equals 2 outside of y subtract 1 squared. Divide both by 2. X plus 3 over 2 equals y subtract 1 squared. Now to get rid of the squared on the right side, I take plus or minus the square root of the other side. And to solve for y, I simply need to bring the 1 over. Second, no, sorry, I left out the 1 there. It's plus 1 equals y. So there's the equation of the inverse. Now, we need to be very careful here, because this equation right here that I've just created, if I were to graph that equation, the graph that I would get would be this. It would actually look like that. It would be the entire sideways parabola that you see back here. That graph right there, the entire sideways parabola, that's the equation of that graph. Now, I don't want the equation of that graph because that graph is not a function. And if I'm going to use f to the minus 1 of x to represent the equation of the inverse function, I better make sure it's a function, because I can't use that. In other words, I cannot write this. This doesn't make sense to write, okay? F to the minus 1 of x is not equal to, I'm going to write that because it can't equal that. I can't write this. The reason why I can't write that is because, okay, that's why I got a not equal to sign. I can't write equal to here because this is not a function. So it doesn't make sense to say f to the minus 1 of x. Whenever you use this, you're saying, here's the inverse function. This is not a function. So I cannot write f to the minus 1 of x equals that. So what do? Well, if I want to write the equation of the graph that I see above, which is a function, it's only half of the sideways parabola. What half? It's the positive part. That's the equation of the graph that you see above. The sideways parabola, the upper part of the sideways parabola is the plus part of this equation. The bottom part of the sideways parabola, this part down right here, is the negative part of this equation. Both of them are functions separately, but together they are not a function. So it doesn't make sense to write f to the minus 1 of x equals this, because this is not a function, but this is. That's a function right there. So I can write f to the minus 1 of x equals, and that is the inverse of the original graph with the restricted domain. Okay, let's look at the other possibility. The other possibility for the restricted domain we said was, what about x is less than or equal to 1? So let's restrict the domain to be less than or equal to 1. If we go less than or equal to 1, then I need to consider these three values. So I got 1, 0, negative 1, and I got 5, negative 1, and negative 3. Actually, it was 5, negative 1, and negative 3. 5, negative 1, and negative 3, and it was negative 1, 0, and 1. There's my table of values for the left side of my parabola. Let's graph it. I got negative 1 and 5. I've got 0 and negative 1. And I got 1, negative 3. No big surprise here. Now I'm graphing the left side of my parabola, right there. But you can see that when I graph the inverse of that left side, the inverse will be a function. Let's graph it and see. 5, negative 1, negative 1, 0, negative 3, 1. Let's plot the points again, and let's join them up. Okay, 5, negative 1. I've got negative 1, 0. And I got negative 3, 1. Here is the inverse function. And that inverse is a function. Vertical line tells me it's a function. So the inverse again is a function. So let's find the equation of that function, of that one that you see there. Well, we just figured out how to switch x and y and solve for y. I'm not going to do that again. The equation we got was this one here. Y equals plus or minus the root of x plus 3 over 2 plus 1. Remember, this is not a function. This is your complete sideways parabola, which is not a function. I only want the bottom part of that sideways parabola. The bottom part of that sideways parabola, which is a function, is the negative part of that equation. This is a function. And in fact, it's the equation of that graph in blue right there. Again, note, very important here, that I can only use this symbol if the equation that follows is a function. I cannot put f to the minus 1 of x in there because this is not a function. I can only use this here. Again, the sideways parabola, the negative is the bottom part of the sideways parabola. The plus part is the upper half of the sideways parabola. So depending on how you restrict the domain, your inverse function will depend on your original restriction. So let's look at some examples. Example 1. The range of an inverse for the f of x equals negative 3 instead of x subtract 2 all squared plus 1 was found to be this, y such that y is less than or equal to 2. What restriction was used on the f of x? So the range of the inverse was found to be this. So this is the range of the inverse. Range of the inverse is equal to the domain of the function. So if the range of the inverse is y such that y is less than or equal to 2, then the domain of the original function had to be less than or equal to 2 as well. The range of the inverse is equal to the domain of the function. So it's less than or equal to 2. Correct answer is A. Again, I encourage you to maybe stop the recording, try these questions before I do them, see if you can get them correct. Example 2. What is the equation of the inverse function if the f of x equals x plus 3 squared with this restricted domain? X is greater than or equal to negative 3. Okay, what I would do here is I would think about the graph, do a sketch of the graph possibly, and think about what the inverse graph would have to look like. Let's do that. We'll find the equation shortly, but let's get a visual of what the graphs look like. This is a parabola. X plus 3 squared is a parabola with its vertex at negative 3 and 0. There's the vertex. It's a parabola that opens upwards. So here's the original graph right there. Very simple graph. The sideways parabola, in other words the inverse, will have its vertex at 0, negative 3. Switch them around. So here's the vertex of the original graph. The vertex of the inverse will look like this, right? Vertex of inverse. So it would have a vertex of 0, negative 3. And again, it's a sideways parabola with its vertex here, and it will open to the right. So let's do a quick sketch of that one. So here is the graph of the inverse. Now we know that that's not a function at this point. Now let's see what we have here. We have a restriction on the original function, though, to be greater than or equal to negative 3. So if the restriction is greater than or equal to negative 3, then really all I should have graphed here was the right side of the parabola. I drew the entire parabola, but we only need to consider the right side of the parabola, because that's my restricted domain. If I consider the right side of my parabola with the restricted domain, then I only need to consider the upper half of my sideways parabola to get my inverse function, because that's what the graph of the inverse would look like. If you take the right side of your parabola, the inverse is going to be the upper half of your sideways parabola. If you take the left side, you take the lower half of your sideways parabola. So here's the original function. Here's what the inverse function looks like. Now let's find its equation. That's important that I did the sketch. You'll see shortly why. Let's find its inverse. Y equals x plus 3 squared. Switch x and y. And solve for y. I'm going to get rid of the squared by doing plus or minus. And I get plus or minus the root of x subtract 3 equals y. Now remember, what I have there is not a function. That's the entire sideways parabola. I want the upper half of that parabola. The upper half of that parabola is going to be the plus part of the equation. So it's this. Y equals the absolute value of x subtract 3. Now, let's look at our four answers here. Y equals the absolute value of x subtract 3. Oh, that's the same thing there. Negative 3 plus the root of x. That's the same as that. So, okay, these two are definitely not correct. So we're down to A or C here. What else is different here? Well, this one's got a restriction of greater than or equal to 3. This one's got a restriction of greater than or equal to 0. Now look at the graph of the inverse. What's the domain of the inverse? Is the domain of the inverse greater than or equal to 3? Or is it greater than or equal to 0? The domain of the inverse is greater than or equal to 0, isn't it? So the correct answer here is indeed C. That was a bit of a tricky one because you really had to think about the graph in order to be able to answer that question. That's why I did a sketch and a graph for you. Example 3. The domain of this function, x plus 3 squared subtract 5, is restricted so that its inverse is also a function. Which is a possible range for the inverse function? Same type of scenario again. The range of the inverse is equal to the domain of the original function. Range of the inverse is equal to the domain of the original function. So, how could we restrict the domain so that its inverse is a function? Remember we said we look at the x-coordinate of the vertex. This is a parabola. It has its vertex located at -3 and -5. So two possible restrictions on the domain would be x such that x is greater than or equal to -3, or x such that x is less than or equal to -3. These are the only two possibilities for the restricted domain. So if this are restricted domains, then the range would have to be, because they're equal, y such that y is greater than or equal to -3 is one possibility, or y such that y is less than or equal to -3. I'm sure one of those two answers are listed there. Y such that y is greater than or equal to -3. Because again, the range of the inverse is equal to the domain of the function. Remember, they're switched around. Domain and range are switched for a function and its inverse. And this had to be the restricted domain here because the vertex was at -3, -5. Example 4. Use the function y equals x squared plus 4x subtract 7 to answer the questions that follow. Explain why the inverse relation is not a function. Well, the reason why it's not a function is because this is a parabola that opens up, right? And the horizontal line test, I'll just write HLT, the horizontal line test tells me that the inverse is not a function. So if the inverse is not a function, they're asking us to now restrict the domain so that the inverse is a function. In order to restrict the domain, I need to determine the vertex of my parabola. So let's proceed to do that. To find the vertex of the parabola, I'm going to use minus b over 2a. So let's do that. To find the vertex, x equals negative b over 2a will give us the x-coordinate of the vertex. That's a -4 over 2 times 1, which gives me a -4 over 2, which equals a -2. That's the x-coordinate of the vertex. I also need to find the y-coordinate of the vertex. Let's go down here and do that. To find the y-coordinate, I simply plug that x-coordinate back into the equation. -2 squared plus 4 times a -2, subtract 7. That's going to give me -2 squared is 4, subtract 8, subtract 7. That's a -4, subtract 7, which is a -11. So I have a vertex for this parabola at -2 and -11. X is -2, y is -11. Not quite enough room there, but we'll manage. Vertex at -2, -11. Okay, it's a parabola opening upwards with the vertex there. Restrict the domain so that the inverse relation is a function. All I need to do is take either the left side or the right side of this function, and the inverse will be a function. So the parabola looks like this, and I'm not going to be real particular about the parabola, but we know it looks something like that, with its vertex located at -2 and -11. The restricted domain will be x such that x is either greater than or equal to -2, That's one possibility. Or, now it only asks for one, but I'm going to list both. X such that x is less than or equal to negative 2. Depending on which of these two you choose, we'll end up with a different equation for the f of negative 1 of x, for the inverse function. Notice again that I chose the x-coordinate of the vertex. I either graph the right side of my parabola or I graph the left side of the parabola. It doesn't matter which you choose. Determine the equation of the inverse. To determine the equation of the inverse, I need to switch x and y and solve for y. Now, if I want to do that, it's much nicer for me to have the equation in vertex form. So I'm going to write y equals, the value of a here is 1. The value of a, this is vertex form. The value of a doesn't change, it's still 1. The vertex is x plus 2 here, because the vertex is negative 2 and negative 11. So there's the equation of vertex form. Let's switch x and y and solve for y. Switch x and y first. X equals y plus 2 squared, subtract 11. Now let's solve for y. X plus 11 equals y plus 2 squared. So we end up with plus or minus the root of x plus 11 equals y plus 2. So we end up with plus or minus the root of x plus 11, subtract 2, equals y. Again, note that this is not a function. The equation that I just created is the entire sideways parabola. This is not a function. I want the equation of the inverse function. I can either choose the plus part or I can choose the minus part. It doesn't matter which I choose here. It really would depend on which of these two restrictions I created. Let's go back now. I know I said that there's two possibilities. Let's go back and choose one of these. Let's go back and choose the greater than 1. And let's finish the question. Let's say you chose, if you had this question, you just chose this as a restricted domain, because you don't have to list both. If this is your restricted domain, then your inverse function is simply going to be the positive part of that equation. So f to the minus 1 of x for that restricted domain is simply going to be plus root x plus 11 subtract 2. There's the inverse function for that restricted domain. State the domain and range of the inverse. The domain and range of the inverse is, again, the complete reversal of the domain and range of the original function. The domain of the inverse is equal to the range of the function, and same thing with the range of the inverse is the domain of the function. Now notice it's the f of minus 1 of x, though. Okay? So let's keep that in mind. We restricted the domain, so the reality is this is what I've graphed right here. I've graphed the right side of my parabola. Now there's my restricted domain. My inverse function will have a vertex, if you want to consider it that, I suppose, at negative 11 and negative 2, because I've got to switch that around. Negative 11 and negative 2. Negative 11 and negative 2. And the graph will look like, because I've chose the upper part, will look like this. So the question is, what is the domain and range of the inverse function? So the domain of the inverse function, look at the graph that I just sketched there now. The domain is going to be greater than or equal to negative 11. And the range is going to be greater than or equal to negative 2. Again, look at the graph of the function that I've constructed here, which is the inverse function, because I'm looking for the domain and range of this inverse right there. I just did a sketch of the graph of the inverse. It's the upper half of my sideways parabola with a vertex at negative 11, negative 2. The domain is the values of x that you can find points on the graph, which is greater than or equal to negative 11, and the range is going to be greater than or equal to negative 2. And again, that's just the opposite of the domain and range of this function you see here, right? The domain of this function is greater than or equal to negative 2, so that became the range of the inverse. And the range of this function is greater than or equal to negative 11, that became the domain of the inverse. Let's have a look at the key ideas before we conclude. You can create an inverse that is a function over a specified interval by restricting the domain of the function. That's what this entire lesson was about. When the inverse of a function is itself a function, it is domained by the f of minus 1 of x. You can verify graphically whether two functions are inverses of each other. And that is this.